So good morning, everyone, and welcome to the JKMRC Friday morning seminar series. On behalf of the University of Queensland and the Sustainable Minerals Institute, I would like to acknowledge the traditional owners and custodians of the lands on which we meet today. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections with country, and we recognize their valuable contribution to Australian and global society. So for this seminar, it is my pleasure to welcome Dhaniel Carvalho. He's a Principal Resource Geologist for Glencore in Australia. With 13 years of experience in mineral resource evaluation, geological modeling, and geostatistics, he brings comprehensive experience in gold, zinc, lead, copper, and polymetallic deposits. He has extensive knowledge in geological modeling and mineral resource evaluation using geostatistical methods. With resource modeling experience in Brazil, Canada, Peru, Australia, Kazakhstan, and Namibia, Dhaniel is responsible for preparation of mineral resource estimates reporting under the JORC and NI 43101 guidelines and resource sign-off. After pursuing a master's degree at the University of Alberta, Canada, focused on probabilistic resource estimation, geometry, and grade simulation, Dhaniel developed further interests in creating automation solutions for a range of challenging resource modeling problems using Python scripting. Today, he'll be presenting a seminar titled Resource Modeling, Its Whole Role in the Mining Industry, Current Practices, and Future Developments. So let's give a warm welcome to Dhaniel.
Hello. Hi. Can you hear me? It's okay. Okay, good. Well, hello everyone. Well, Dhaniel already made a big introduction of me, so thank you very much for the invite. It's a pleasure to be here doing this talk for everyone. So yeah, I'm going to talk about resource modeling, the importance in the mining industry, some of the practices that we have at the moment, and also some future developments. Hope you guys enjoy. So I'm not going to go into this too much because then already give this introduction, but I'm originally Brazilian, and that's where I lived for a couple of years before worked as a resource geologist for a couple of years. Then I moved to Canada to pursue a master's degree in geostatistics and resource modeling. And that's where I started working with Glencore at the time as a senior resource geo, then moved to Australia a couple of years ago to become the principal resource for the zinc assets here. Okay, so just before we start, I'm gonna set the expectations so we're all aligned. And I'm sorry for the more experienced resource geologists or just statisticians that might be watching this. This is not an in-depth explanation of each one of the topics in the resource modeling. It's not going to be too theoretical or prescriptive. Oh, you should be using this or should be using that technique. And it's not a description of complex techniques in general. My goal with this is to bring an overview of the resource modeling and to bring awareness of the topic for exploration geologists, mine geologists, students as well, trying to be informative about this field and how you can apply in your day-to-day. And I'll give some examples and resources and tips. Cool. Alrighty, so the summary. I'm going to talk about very quickly about what is resource modeling, the importance, some of the current practices that we have, future developments. I want you to pay attention on the current practice and the future developments because there's a big difference there, and I feel like the future is already happening, but I'll get to that point. Some tips on how to become a resource modeler if you're keen to. There's not a single right answer for that. There's many ways that you can become one, but it's possible. And then a very quick, short conclusion. Alrighty, so what it is. As I mentioned, I'm going to try to give a very a quick explanation so you can grasp the whole idea of the resource modeling. And first, for me, the simplest idea is you're going to model your geology in 3D, calculate volumes, calculate tonnages and grades, and then you're going to use that information for decision-making in the future for mining projects. Okay, that's the very, very simple idea on that. Okay, so you start with your drilling. So that's the drilling or all of your data. This is one deposit here in Queensland. Some of you might know where it is and what it is. But you start with that drilling data. and in your deposit. Then you have to ask what we're going to be modeling here. So we're modeling the geology, the mineralization. You should be modeling everything possible, right? But that's where you start. Then you generate a volume of interest. In this case, I'm just showing here a mineralization volume, and that's where we're going to do some of the estimation. But that's all based on the geohole data, mapping data, and any information that you have available in the project or deposit. Just showing a cross section on that same model. So we can see here it's just showing the mineralization domain that we just modeled, and we have our drilling. So what do we do from there? We should be also doing a modeling of the geology in 3D. So all of the stratigraphic sequence, the weathering surfaces, faults, transitional zones, everything needs to be modeled because this will all go into a resource model at the end of this process. So in this case, after we do the modeling of the geology, then you need to do the estimation, in this case, copper grades. You need to do the estimation of the copper grades in 3D, and you do that for every XYZ location on your volume of interest. That's an estimated block model of copper grades. So then you have to apply some cutoff grade because not all of the mineralization will become, it is economic at this point. So you need to apply an economical cutoff grade to understand what will make money out of it. So which portions of the deposit will make money, will have a profit. So then with this estimated block model, you can understand the grades distribution around, spatially distribution of the grades in your deposit. You can understand the tonnages, the metal, and the grades, and do all kinds of analysis and decision making with that information. All righty. So just on an example here. So this is a very quick overview on the deposit life and where the geological and resource modeling sits. And I say is that it sits around the geological interpretation and the estimation and geostatistics. Of course, all of the other portions are very important, but I'm going to focus on the modeling itself. And it's basically a big loop here from exploration to mine planning. You do this iterative process all the time. So it means that you're going to update your resource models hundreds or even thousands of times in the mine life until the closure, right? But I'm going to focus on those two aspects. But yeah, before I start talking about how we build those geological models, those resource models, I want to discuss the importance of it and what can be achieved with those resource models. Yeah, so as I mentioned before, once the resource model is finalized, there will be many decisions. They will serve as a foundation for many decision making in the mining project, in the mining business. And here are some of the topics that I'm gonna talk about. So exploration, technical studies, operation, reporting to the stock market, and as well for closure and merge and acquisitions. Okay, first of all, so allied with geophysics and soil sampling, regional mapping, and all of the information you can have, you can generate some block models that will probably not be a resource model per se, but that will help you help with the target generation. So for example, for greenfields targets or greenfield exploration, you can use a block model to try to define a deposit signature together with all of the other information that you have. I feel like it's more common that you use some of these resource models or block models in the brownfield or near mine, because those can assist you to extending the life of the mines and the existing projects that you have. So you generate those block models, design a geohole plan, and then you can extend the life of mine near the mines. So here's just one quick example of a successful case like that. Of course, it was not only because of the resource model and only because of the drilling, but it's part of that is an extension of the Ernest Henry mine that extended the life of mine until 2040, and that's a portion of the mineralization that it served as the purpose of the near mine exploration that increased the resources in almost 100%, I think. But it's not only that portion, but it's a good example. Cool. So another very important topic that, or important usage of the resource models are for the technical studies. So we can use, I recommend you guys read the JORC code and to understand exactly what each one of those phases or those stages are. But you start with a concept study, you have a deposit, you find your deposit, it's reasonably well drilled. Then you need to understand if that deposit is feasible, if it will make money from that. You start with a concept study, then you transfer to the pre-feasibility and feasibility, and then which means that you increase your knowledge when you go from concept study to the feasibility study. And the base of one of the bases of all of this understanding and of those studies will be the resource model, will be the geological model and the block model that you estimated the grades. Yeah, I mentioned that. So this will support you in the drill hole planning, the mine planning, and advancing the financial models and advancing on with the project life. Okay. And just before you think that this is just a random picture with camels, that's actually the Oyo Togoi area, the project from Rio Tinto. That's a very good example of a successful project that went through all of the different stages and is starting operations right now. But yeah, for each one of the updates of the concept study to the pre-feasibility and the feasibility, you have drill hole campaigns, you have sampling, which means that you have a resource model update. So your model changes. But it is very important so you can make the decision out of it. It's very common that you reach to a point that the model shows that the project's not economic anymore, so you have to stop, look back, and see if there's anything that needs to be changed. Cool. So this is another important aspect of the resource models and where we can use it. It's the operation. This is probably where the most of the time the block models and estimations are used. Maybe not as a resource model, but we can call it a short-term or a grade control model. And this is where you're going to have the daily decision making. Okay, so you're going to incorporate all of the data from your short-term, your sampling, your mapping, your short-term drilling, and then you're going to do updates of your block model. With that information, you can send to the mine planning and then update the dig limits, the stope designs, and all of the subsequent steps. But it's for the operation and the updates of the block models, they're key for the mine planning. It's crucial. And this is where you're going to have a better definition resolution of the ore and waste boundaries. You have more controls on the geological features. It's also pretty important that you perform reconciliation against production. So then you can update your drilling plans, see if there's anything wrong with your model, and then update the estimation parameters or the modeling itself. There might reach a point that you're undercalling your tonnage or your grades for the whole year. So you have to understand, okay, before you get to that point, you go back, change your resource model based on the reconciliation results. Not only, but the reconciliation is a very good parameter. And it's also very important, I'm going to talk about automation later, but in this universe, let's say, it's important that everything is quite automated, that you have validation very quickly and automated to get the results quite quickly to make that decision very fast and accurate. Another important topic or usage of the resource models are the reporting. So for all of the big or small companies that are listed to the public, listed in one of the stock markets, they have to disclose an update of the resources and the reserve at the end of the year, if there's significant material changes on the resources. But yeah, usually it's once a year, and it's important because the disclosure of the mineral resources and or reserves, in theory, is to help us to allow the investors to make an informed decision about the company, right? So you saw there for Glencore, Rio, BHP, this is the amount of resources that we have, this is the amount of reserves, and they can assess, in theory, the health of the company on the resources and how they're making. But it is quite important that you're going to use those block models to do that reporting at the end of the year. Yeah, and there's a couple of different. They're all scandals with the mining in the mining business. Then resource models are related to some of these scandals. Like One of them is the BRIEX. It happened in 1997. I really recommend you guys watch the GeoHug that talks about the BRIEX, and also the movie from Matthew McConaughey. It's fun, and the movie is based on this happening. But it was what was happening for the BRIEX is that the geologist, always the geologist, he was salting the samples, and it was increasing the grade of the drill holes, which is crazy, and that inflated the resources a lot. Another interesting one that happened a couple of years ago, and before I go forward, what I'm talking here is that because of the disclosure of this material and this resources and reserves, they can have significant impact in the share price. So that's why this is very important. But yeah, the Rubicon, the second example, happened in Canada a couple of years ago. So this was a huge problematic resource estimate error in a way that overestimated the resources a lot. So there was a resource model update, I think it was 2016, and the resources dropped 88%, which means that, and that had direct impact in the share prices that dropped 64% at that same day. So whatever you're doing when you're using your leapfrogging, your RMSP, doing estimation, it can have huge impact in the real life. I mean, everything has, but. And the last one is the red pine, which is very, very recent. I think was maybe a month ago. So the previous CEO was also, he was changing the assay grades from the labs. The labs were saying one thing, and then you look at the assay tables, they had more grade than they had before. So that has also direct impact into the resource models and the share prices. Because when they publicly disclosed that, what happened is that the share prices dropped 58% in that day, which is very important, very crazy. Alrighty. Another important point in the usage of the resource models, it's on closure and on merger and acquisitions. So once you're starting to go to the end of the life of the mine, so how much resources left? So you have to, again, go study the JORC code. I really recommend you also do the JORC code reporting course from ASIMM. Maybe when you reach to the point of closure, should we update the RP-EEE? Because the resource that we have will be different than the reserve, but it's something that you have to think at the end of the life when you're updating your geological model, your resource models. Also, so how do you value a deposit or a company for an M&A? It usually starts with due diligence. I myself was involved with tens of different due diligence around the world, and usually starts with the geology. Of course, there's all of the other portions of the evaluation, the financials, the mine planning, but the geology is one of the starting points, right? You have to look if at the deposit and see if whatever they're saying that there is in the ground is sound, right? So for all of these examples of merger and acquisitions like Barrick and Randgold, Glencore and Xstrata, the Evolution deal with Anasari a couple of years ago, and even the recently failed bid from BHP with Anglo, I'm pretty sure that there were many geologists involved in reviewing the resource models for both of the companies. Cool. All right, so now we understand why the resource model is important and some of the applications of the resource model. So I feel like it's time for us to talk about how do we achieve that? How do we make those models to generate the volumes? And one thing that I wanted to be very clear on this current practices is this is the average model that you see in the industry, right? There's lots of advanced techniques that we have available at the moment, but when you look at, let's say, the median model in the industry, it will have these practices, which can sound pretty simple, but I feel like that's the reality. So that's the average model you see around the industry. Oh, very quickly on the typical mineral resource estimation workflow, we start with the database validation. We go to geological modeling, do some EDA. You can do some EDA before or after geological modeling. Those are not exactly like a straight line. You do density modeling, the estimation, resource classification, and then you validate all of those results. Ideally, you validate for each one of the steps as well, not only at the end, but at the end is where you can see the final results. And again, I'm going to focus on the resource modeling portion of it. So I'm talking more on the geological modeling and estimation and EDA. I think it's also important to note the existence of geostatistics. I'm not going to focus on geostatistics, but this is a very important field that will solve many of these problems especially on the estimation side, geological modeling and EDA. But this is a whole field that it's maybe part of the resource estimation or the resource modeling. It's both part of the same thing, but I'm not going to focus too much. But we're going to use geostatistics a lot to do the estimation and the modeling as well. Okay. And one thing that needs to be very clear is that all of this is very heavily software oriented. So there's no way around. Whenever you're doing your 3D models, your estimation, your simulation, you're looking at a computer and doing the modeling there, right? Of course, all of the data acquisition and the mapping and the understanding, it's in the ground, but lots of the resource modeling itself will happen in front of a computer. All right, cool. So you load the data in your preferred software, you make some geological interpretations, and then you generate the wireframes for estimation domains, the structures, alteration, leaching. So any geological feature that exists in the mine and they're significant for the resource modeling, significant for the project, you can model and you should model, right? But it is important. This is just one example of a zinc deposit here in Queensland. Some of you might know as well. I know you do. But yeah, and this is a very, very interesting one because you have a very well-defined stratigraphy. The R horizon is pretty well behaved. There's a couple of structural features that are very interesting in this deposit. But once that model is done, I have to say, make it clear here that this is a deterministic model. So you have only one model. After you finalize your interpretation and do all of your geological modeling, you have only one. And that's why we say that it is deterministic. There's many ways that you can generate those volumes and those wireframes. Right now, there's always this discussion about explicit and implicit modeling, not explicit versus explicit modeling. And explicit modeling, the way that you generate the wireframe is that you do hundreds of different sections or plant sections, and then you link together all of those polylines together, generating a 3D volume. The difference for the implicit modeling is that instead of generating those hundreds or sometimes thousands of sections, you generate the surfaces with interpolation directly from the drill holes. And I feel like it's also very important to talk here. Well, Danny Cantwell talks about this from SRK, is that you should destroy the distinction between explicit and implicit modeling in the terms that both the techniques can produce very bad models and very good models. The difference there is that one will be much, much faster than the other, but both can produce all kinds of garbage or very good ones. So yeah, there's the difference in between the two ones. There's also ways that you can generate those geological volumes using geostatistical methods. And that's where I'm going to put this big X here, that it doesn't mean that the big X, this is bad. It just means that the average model that you see in the industry right now is not using categorical simulation. I'm going to talk about simulation after this. But that's what the big red X means, is that the average model that we see, it's not using probabilistic resources or probabilistic modeling. But there's lots of people using right now, but it's not just the average. Right, so now you have your volumes, you have your wireframes, your geological models. Now you need to populate that with estimation. So you do some statistics, some general data analysis. You want to understand what's the overall characteristics in between the different lithology types, different deposit types, or different estimation domains. And you also want to do some calculation. You want to understand if the relationship between all of the variables is sound, right? So you do your statistics to see if that's making sense after your modeling and before as well. So you after that, you do some variograms. So you calculate some variograms. But the variograms is a tool that we use, statistical tool that we use to understand the spatial correlation in between the samples. And the variogram will be used for most of the geostatistical techniques that we're going to talk about. So good, you do some statistics, you have your volumes, you do statistics, you have your variograms to start doing your geostatistics. So now you have to calculate that into the block model. So the block modeling, the block model is a discretization of the volume. So you have all of the volume and you discretize that in tiny little 3D blocks. And for each one of those tiny little blocks, you're going to do an estimation of the grades or of any type of characteristics in there. Okay, so the block modeling is that discretization of the volume. In order to populate that volume, you can use interpolation, you can use estimation. So for the average model that you see out there, you're going to see lots of inverse distance, and most of them we use ordinary kriging. So ordinary kriging is just a technique to optimize the estimation based on minimizing the variance. So it's a very good estimator. It's probably the one most used out there. But then again, both the inverse distance and the ordinary kriging, they're also deterministic. Once you finish the model, you're going to have only a single one. Right now, there's lots of people using simulation, so you can have a range of realizations of the possible grades in that deposit. But then again, big red X, not saying it's bad, it's actually pretty good. But the average model that you see out there is not using simulation for the grades or even the model. Once the resource model is calculated, you have the grades, the tonnage. Now you need to classify that into measured, indicated, and inferred based on the JORC code here for Australia. And measured, indicated, and inferred is just how much certainty you have for those specific volumes of your deposit. So from inferred to measured, that's where you increase your certainty. So there's areas of your deposit that's not well drilled, that's probably going to be inferred, reported as inferred. And the areas that it's more heavily drilled, that's where you're going to have measured resources. Cool. All right, so that's how we do it right now. The average model, that's how it's done. And so what are the next steps? So what are the future developments on resource modeling in my view? And as I said, this is cheesy. The future is now. Yes, this is cheesy. But what happens there, it's a little bit disappointing to talk about the future when I'm talking about the next slides is actually the stuff that already exists right now. It's just not largely applied, implemented. So it feels to me that all of these methodologies talking here, they're all available. They might be a little bit more difficult to implement right now, but there are many reasons for that. It's also important to state that the mining industry is quite conservative when it comes to implementing some of these new techniques and new technologies. The reasons for that might be just lack of information or formal education. Sometimes inflexible software is also a case for implementing some of those, or even too complicated software. But yeah, there's some resistance on implementing some of these new techniques, but they already exist. They've been existing for decades, actually. All right, so the main point here for me, and when it comes to the future of the statistics, future of the resource modeling itself, it's when the average model will have a probabilistic workflow. So it's not a deterministic model anymore. And the probabilistic workflow, when I talk about it, is the simulation. So you have multiple scenarios of the same data, right? So it's important to understand that, because that will allow us to understand the uncertainty of the volumes, and understand and do some risk analysis of the geometric uncertainty. And for the probabilistic workflows, as I mentioned a little bit before, you have continuous simulation. So that's when you do the simulation of grades on your block model or any numerical values. There's a bunch of different techniques that you can use to do that. There's also categorical simulation. So that's when you're doing the simulation of the geology or some lithological feature. And as I mentioned, there's many applications you can use. Volumetric, grade, metal, uncertainty. There's mining planning risk that can be understood. Drill hole planning and drill hole optimization. You can optimize your drill hole spacing using simulations. But yeah, I feel like this should be the future for the average model, let's say. Some examples over there, you can see on the top right corner, there's an internal report from Glencore, from us, and that's with RMS, so the resource modeling solutions. In that case, we're doing a simulation of the stratigraphy. So instead of having only one model, we have hundreds of different models for the stratigraphy. You can see there is some variation. It's not huge for that specific case, but it allows us to understand what are the risks on the metal and some even environmental risks. There's another example here on the left bottom corner in black. You can see that was presented by Craig Williams in the International Mining Geology Conference 1 month ago. And what we can see there is the simulation of transitional zone in a nickel deposit. So you see the more red you have, the higher the probability of having that transition zone over there. And then the colder colors is the lower probability. That allows you to do some understanding on the uncertainty. A lot of understanding actually. And another example here on the left side, that graph from Laércio Bertossi that was presented a couple of years at APCON. You can see the uncertainty of the niobium grades in each one of the years. So you can imagine that the next couple of years that you're mining measured indicated areas. And once you start mining some of the inferred areas, you're not going to mine inferred, hopefully. But once you start getting to the inferred zones, that's where you have a big range of the uncertainty on the grades. So that's a very good way that you can mitigate some of those risks. And plan accordingly, right? So you can do drill hole planning. For me as well, in the future of resource modeling, again, this is something that lots of people are already doing, but you look at the average model, it's not in there. So you have more data, you have more software tasks, there's more challenge all the time. So you have to have some kind of a scripting. So it's not only about the estimation. There's a lot that you can take with the scripting from the geology, from your resource models. So that will allow you to do lots of data analysis, automate plots and graphs generation, some spatial and 3D modeling, and also some block model manipulation. So in the future, you need that flexibility. You need to act fast so you can have more time to think about the geology itself and not be point and clicking your way out to an analysis, for example. And more we have this comprehensive workflows that will use multiple software, multiple platforms, all kinds of different file types and data. And that's an example that I have here for the Sabre framework from BHP. So Ilnur presented a year ago in the Mineral Resource Estimation Conference. And for me, like in this specific workflow, there's many Python scripts. You're joining different platforms like Sequent, Leapfrog, and RMSP, and all kinds of different files, everything running in the cloud. For me, this is probably one very good example of how a future workflow will look like. Cool, another one, the buzzword, AI and machine learning. I'm personally, to be very transparent, I'm not a specialist in machine learning and NI, but I'm some kind of an enthusiast, and I can do some damage here and there. But for me right now, what I can see is that AI can work in two ways for the resource modeling itself. One is as a support for the resource modeling, right? So it can help us do some multivariate clustering of different assay values and any kind of information that you have to understand your geometallurgical domains, to understand the lithological domains. Align with that as well, core scanning, right? So all of the imaging that you can generate, hyperspectral imaging, LEAPS, all kinds of examples that you can grab the information from there and then implement into your workflows to generate the resource model. So you can have more informed data to generate the wireframes and generate the estimation and models. Right now, there is some research. There's a couple of companies that are doing some direct modeling and direct estimation workflows using neural networks and some other machine learning techniques. Still feel like this is a little bit gray still. There's some academic research on it. Maybe in the future is something that will substitute the geostatistical tools that we have, the traditional geostatistical tools that we have right now. But I don't feel like that's what's happening right now, but maybe in the future. But definitely as a support, I feel like every resource modeling workflow should use some machine learning to help with the data analysis. Cool. So now that we talked about the importance, how people are doing that in the industry right now, how should we probably be doing that in the future? So just a couple of tips on how we can become, or you can become a resource geologist if you have interest. And then again, there's no right answer for this. There's not only a single way to do it. There are all kinds of flavors of resource geologists. You can focus on something at some point in the beginning, but I feel like for me, balance is key in the way that you have to be strong in all the areas. You might focus in the estimation at some point, or you might focus on the geological modeling, but you have to be strong in all of the areas so you can be very flexible and you can defend the work that you're doing. It doesn't matter if you're doing the most advanced geostats possible. If your geological model is not sound, then your geostatistical will be also garbage. And the opposite as well. It doesn't matter if you do an amazing geological modeling, but then your geostatistics is not sound. That's not great. So you have to be quite balanced and strong in all of the different fields. So yeah, if you one of the tips here. So if you're a student and you want to come to this field, my advice is go to the industry, go take a look outside, see what they're doing there, what the challenges that they were doing there, they're having, and how they do the resource modeling out there. I've been in the academia for my master's degree just 2 years, and it was a game changer for me. But I feel it's very important that if you want to become a resource geologist, you can go back to the academia, but go to the industry, see what's happening out there, and then come back if you want. If you're an exploration geologist or mine geologist or engineer, because it can also be an engineer and resource modeler. My advice is that also you go and look to the other side. So if you're an exploration geologist, try to work a little bit as a mine geo. If you're a mine geo, try to work a little bit as an exploration geologist, because you're going to complement the different skill sets for each one of the different roles. What I also recommend if you're already in the industry is that find the nearest resource geologist, maybe a leader in the company, like a manager of resources or a principal resource geologist, and see how you can link your activities to some of the resource modeling. This person will probably be able to give you some hints. Maybe you can start with a small project like a brownfield project or an extension of your mine. You do the modeling over there, do the estimation, and you go from there. So it's very important that you start with that small one, and you're going to need a big chunk of your time doing that modeling so you can get comfortable with the subject. Okay. A couple of essentials. So for me, it's very important. It's not all of the resource modelers that I know that have a mentor, but I truly recommend you find a mentor. I had a couple in my a couple of mentors in my career, and they were essential for my development. So I feel that's very important. That's the person that you will, because if you start in this role, you will hit hundreds, thousands of roadblocks and dead ends, and you don't know how to get out of those ones. So if you have a mentor, that person will probably take you out of that dead end and help you with the task. And that's where you learn. For me, at least, in my experience, that's how I learned a lot doing the job with a mentor. This is the same person that you will bother with thousands of questions, and is the person that will also probably start giving you more complex projects and projects that will demand more responsibility. So you increase the responsibility as you go. You're not going to get Mount Isa copper to estimate in your first day as a research geologist, right? So you're going to get a small, tiny little one, and then with time, you're going to do the estimation of something big, something very important. But you have to start small. And then again, you're going to need some years doing this until you get very comfortable with the resource modeling. It takes time, but you can do it. Another thing that it's also important is that you also have to honor the geology. As I mentioned before, doesn't matter if you're the best geostatistics guy in the world, if your geology is not sound, if the input is not good enough, that's not going to help you with your model. And the opposite as well. But definitely honor the geology. See the results of the Parker Challenge that we had last year in the Mineral Resource Estimation Conference. The geology, the interpretation and the domaining was probably the ones that had most impact into the resource models that we evaluated at the time. So honor the geology. Learn the software. Cannot stress this enough. As I mentioned, it's very software oriented. I know many of them, and this will allow you lots of flexibility, right? So if you're changing projects, if you're changing companies, it's important that you know many different software so you can have that flexibility. That helped me a lot adapting to a new role or adapting to a new company when I moved different projects. So do learn the software. Don't stick to just one. Learn a bunch of them. And also very important for me specifically, I say that there's some resource geos that will say the opposite. They don't like that. But in my view, you have to learn scripting. You have to, and in my case, I'm gonna recommend Python just because I love it. But do learn scripting. That's powerful. It's extremely powerful. It will allow you lots of flexibility. And for me, same as my master's degree, learning some Python and learning scripting was a game changer in my career. It will allow you lots of flexibility and work on your development. Yeah, and one thing is it's important as well is I recently started using ChatGPT for my coding, and it is pretty powerful. But you have to know your coding, right? But you can use ChatGPT to help you with the coding itself. There's a couple of examples that we do that in Glencore that I talked to the guys. Some workflows that I know that it would take me maybe 3 weeks to do it by myself and just Stack Overflowing the results and then the answers. But with ChatGPT, it takes me, I don't know, 2 hours, 3 hours, not even. So it's very powerful. But you have to know, because sometimes ChatGPT brings some information that it's not helpful at all or wrong. So you have to know the scripting. Another tip that I can give you guys is to keep studying. Don't stop studying. Always keep learning, keep learning. And for me, formal education can be a game changer. There are some of the classics over there that are very well known into the resource geology or geostatistics world. Personally, myself, I took the citation in applied geostatistics in Chile a couple of years ago from the University of Alberta. That's where I met my supervisor at the time, Clayton Deutsch, and that was a big game changer for me. Other very important ones, like the ones at Mines Paris, the geostatistics course, it's very well known, very, very good. A couple of good courses in Brazil as well, if you're Brazilian. But here in Australia, you also have some pretty important and interesting courses that you can take. I didn't take any of those specifically, but I feel that they're very, very well known. And also, don't just stick to the geostatistics or to the resource modeling. Go back and study your geology, right? So go and study, because you need to generate the geological models and you need more geological knowledge to get that. And you have some other resources here. So courses from RMS. I've done a couple of them, pretty good. There's Snowden courses as well. They're very well known in the industry. There's some free resources like the Geostats guy YouTube, Michael Perks, a very good guy, and the Geostats lessons, the guy from U of A, and with Clayton Deutsch as well. It's a lot of free material that you can grab and learn. And also some structural geology, the course that John Cohen's also developing right now to go back to the structural, to the basics geology. And just to finalize here, then again, wrapping up. So resource models, for me, they're foundational for many decisions that we have to make in the mining projects in the mining industry. I showed also some of the examples on how that can affect the stock market and the company's prices. So it is quite important. There's a lot of impact, not only there, but also into the communities. If you find another mineralization, you can extend the life of mine. The community will be glad that you're continuing that. Some of the current methodologies, as I mentioned, they are well established. That's the average model that I see. You generate your wireframes, you do your estimation using ordinary kriging. That's the average model you have out there. There are many people that only use simulation, that only use advanced geostats, but when you look at the industry, that's how it's done for most of the time. And as I mentioned before, many of these future techniques are already developed. They're just not yet largely applied. And I see that the future of the resource model is the one once we can get all of those techniques into our average model. And then again, anyone can become a resource geologist or just resource modeler. It just requires lots of exposure, lots of time, studying, support. So you need the support from your leader to become one. I mean, you might become like a lone wolf, but it's usually harder. It's better if you're doing with someone, if support from someone, or a company or anything. Thank you very much, guys. Hope you guys enjoyed this conversation. You can feel free to reach me on LinkedIn, or well, Daniel has my email as well. I'm very open to have discussions, and I talk to everyone that has some tips or wants to do some different projects. I'm keen to help. Just so we can get it recorded here on the YouTube as well. Some of the books and papers and other recommendations that you can read. And some courses and educations that I discussed there. There's the links and the information out there. Cool. That's it. Thanks, guys.
All right, thank you, Daniel, for the presentation. Pretty nice. I'll start with some questions. A lot of the resource estimations, especially focus on the assays itself. But nowadays there is a lot of new techniques that we can add a lot of mineralogical data, texture, and even more stuff. How much value do you think this can bring to the resource itself or the life of a mine, and like how much return also financially can you get out of it? And how to integrate mineralogy? You can have more quantitative data, but like how to integrate maybe at some point texture to some model? How much trouble this is gonna bring to do a new model?
Yeah. Very good question. I'll probably ask Kat to respond that to me. I'm kidding. Kat is our senior geomat from Glencore, zinc. But I feel there's a lot of value on getting not only the assays, right? I feel like right now the average model is a little bit simplified. We look at many different assays, but we don't look at other characteristics, as you say, mineralogical, textural, and all of the different aspects that are not only into the assay. So I feel it is very important that we do that, and that's why I try to link into some of the machine learning portion to the future. You have to integrate and find a relationship in between all of these different features with your assay data, so you can get something better out of your geological modeling, the recovery models that you're going to calculate, their geomat. So it is quite important. I feel like it's a little bit tricky when you're in the industry to try to justify. It's hard to convince the managers that this is very important. They're very used to, okay, we only have assays data and then the logging, and there you go, because it is quite costly sometimes to get some of that information, right? It's not as easy as an assay nowadays. But it is critical for me. That's also the future. You have to have that in your models. Do some probabilistic workflows using those features, and yeah, definitely recommend it.
Thanks, Daniel. That was fantastic. I actually just a comment first. I noticed one of the book titles in the list that you put up was called "Snakes, Ladders, and Seduction" about resource modeling, and I tell you that's got to be selling the sizzle, not the steak.
No. That's actually a GeoHug presentation from Lucy Potter, but it's also it's kind of a similar talk that we're having here about resource modeling, but it focuses on the resource geologist career or path, on how you can achieve or become a better resource geologist and time. But
cool. So I just wanted to grab me, but my question, comment, and question. We've got some a fellow here, Daniel Hastings, doing some really interesting research on incorporating ESG factors and financial implications of ESG factors into block models directly. Is that something you've considered at Glencore when doing project evaluations to try and physically incorporate the ESG costs into a block of rock?
It's not something that we are applying at the moment. I feel, again, that's very important to have, but it's not something that we have at the moment with Glencore. I know some other companies are starting to generate that information and apply to the block model, so we can understand how that can affect financially, or not only financially, our projects. But it's not something, again, in the average model, it's not in there. It's the average model that we have right now. It's pretty simplified, but it should be using some of that information for sure.
Right, thanks. For online question from Peter Stoker. The probabilistic model being used in mine planning, or does the average or median outcome end up being used?
Yeah, that's one problem that we have to discuss with our mining engineers friends, is that for the mine planning usually we use only one. The current software, there's some academic research on getting the mine planning to use the probabilistic workflows. So each one of the realizations, you can get some sort of optimization results for the mine planning. But then again, right now, that's not something that it is happening at the moment. I feel like in that perspective, that the resource modeling is a little bit more advanced in the probabilistic workflows than the mine planning is.
Another question from Sheila. Could you explain more about the link between the environmental risk assessment and the resource modeling?
Yes, it is a little bit classified, but what we can do, for example, is that you can use, let's say you have possible acid formation material, right? Then you know exactly which portion of that of your deposit will have that path material. So you can use the resource modeling and the probabilistic resource modeling to generate different scenarios to understand, okay, this is probably the tonnage, the average tonnage that we'll get of that path material, but you also have a range. So with that range, you can plan ahead on the footprints of the waste dump that you're going to use for that path material, right? So that has direct impact onto the planning of the waste dump, for example.
Thanks, Daniel. That was a really, really interesting talk. Very well presented. My question is, I remember having a discussion with someone from a major mine in Australia saying, oh, won't it be great when we can take the stope drilling and the blast hole drilling and instantly update the resource and modify how we carry out the mining and plan where we take the material and deal with geometallurgical variations and all that. And the response was, yeah, no, we planned that stope months and months ago, and nobody's going to change it for love or money. Yeah. So do you think that that's ever going to change? I mean, I guess my question is, are we going to be able to increase the frequency of resource updates and I guess planning and execution of the mining to reflect the frequency we can update resources, or is that just an impossibility?
No, I think it is possible, but you have to align to ally with some different maybe techniques. You can do multiple resource updates pretty quickly. You have some instances in the industry that you do have kind of information. You get the drill hole database updated, that goes automatically into a workflow. The estimation is run in the cloud, and then the resource model is already exported to a file or to a folder in the server that the mine engineer can go there and evaluate that. But sometimes what's happened is that depending on the complexity of some of the mines, the scheduling can be quite complex. So it doesn't matter if you're changing too much, you're just going to go there and mine that stope, as the person said to you. But I feel there is a possibility that we can get there. One thing that we have to change maybe in a way is that the amount of time that it takes from us to get the sampling, get the samples to the labs and back, do all of the checks, the QA/QC, and then get that to the database so we can do the resource model. The portion of the resource model is pretty quick. So you have to figure out a way before getting all of that information to the database and then update the resource model. The resource model is quite quick and easy to update. It's just files and scripts.
So one area I've mucked around with in the past is to do with the density model, because the density model makes a massive difference to the outcome. Even if the grade looks good, it changes quite a lot. So what are your thoughts there about, I suppose, some of the pitfalls and the best ways to create a really good density model?
Density model. Yeah, it's pretty important because usually what happens is that we focus a lot into the volume generation, the wireframing, we focus a lot on the estimation, And then the third part that will create the metal is the density. We just like, yeah, just apply an average or apply whatever, or do some very quick estimation. It will really depend on the deposit type that you have and how that density correlates to some of the elements and some of the grades or the lithology. But there's not a single one way to do the density modeling, but I feel like if you can do some type of a multilinear regression, if you do have that kind of correlation and it is linear, why not? I've seen people using some random forest, for example, for doing the density modeling. That's a little bit trickier because in the conventional software, you won't be able to use that random forest model into the calculation, but you can export that and do that in Python, for example. But I feel it's key that you need to find what drives the density for that deposit and then do that correlation and modeling. I'll say regression, random forest, sometimes just the average works. Not always, but sometimes it does work. But it's important also that you check that density with some of the reconciliation results that you have to see if that's, well, is this true or not, right?
Right, so there's an online question from Carlos Fonseca. Could you give your thoughts on reporting uncertainty in MR or OR? Is that something that you guys are doing at Glencore?
No, we're not doing that.
Can you just explain first what's MR and OR?
MR is mineral resources and ore reserves. Yeah, mineral resources and ore reserves. So the reporting that we do right now at Glencore, we follow the JORC code. And the JORC code, I mean, it states that you can state the uncertainty, but at the end of the day, you state 1 tonnage, 1 grade, and one metal for all of the different deposits. So it's not something that we're doing right now, if I'm correct. NI 4311 is starting to look to get some kind of uncertainty into the reporting side. So you're gonna report 1 tonnage, 1 grade, but you're also gonna report some sort of a range. That's good because it brings transparency to the uncertainty of your deposit and the report that you're giving to the public. But that's not something that we're doing at the Glencore right now. At least not in zinc.
There is another online question. So it's from Alejandro Machi. Are there already examples applied to the industry in ATPG to geology modeling?
Yes. Yeah, there are many people using ATPG. ATPG is hierarchical truncated pluri-Gaussian simulations. That was developed by it's a big name. It was developed by a big friend back in University of Alberta, another Brazilian, Diogo. That was his PhD thesis with Clayton. Yes, so there's lots of people using ATPG. I know that in BHP, there's a couple of guys using there as well. I'm not sure that we use in Glencore still, but yeah, there are many examples and many people using around the world.
Right, it's there. Oh, Tom has another one. Oops.
JORC's been like updated and the reporting criteria has been changed quite a bit over the last 20 years. Do you think it's where it needs to be right now? Do you think it is sufficient in terms of providing a surety to investors when appraising a deposit? And if not, like, where do you think it can improve?
Yeah, I feel like it is important somehow so we can drive that innovation and then that transparency. I'm not sure how efficient it will be because, as I mentioned, you look at all of the resource models that we have in the industry right now, they're all kind of stiff to that same deterministic workflow. Not sure about the efficiency, but maybe it's something good that could push the industry to go for that disclosure of the uncertainty.
All right, I think that's all we have time for today. Thank you very much. I would like everyone to thank Daniel again for his presentation.
Thank you.